Welcome to our lecture on the water treatment process. The original lesson was written by Yanhui Fang, and this lesson was adapted and presented by Danielle M. Demore. This video has been funded by NSF's Boat of Knowledge project at Ohio University. Ask yourself this: where does our water come from? What kind of water is safe to drink? What are some reasons you might need to treat our water sources? How can you treat water to make it safer? Pause the video now to discuss these questions. So, what is water treatment? Water treatment is the process of removing particles of all shapes and sizes from water used for domestic purposes. This could include water for drinking, washing, or agriculture. The more noticeable effects of this process is the removal of any visible dirt, unpleasant smells and tastes, or any unwanted textures. The less visible, but arguably more important effect of this process is the removal or elimination of any disease-causing agents, such as toxins, bacteria, viruses, and many others. We will now review the steps taken in a typical water treatment plant. Before anything else, the water must be taken in. Intake occurs at a variety of sources. Raw or untreated water is pumped in from a natural source, such as a lake or river, or a man-made source, such as a dam, a well, or a holding tank. Water is then directed towards the coagulation and flocculation tanks. Once the water is taken in, various chemicals will be added. These chemicals usually have a positive charge. This allows them to neutralize the negative charge of dirt and other particles by binding with these particles in suspension. One of the most common chemicals added to water is called alum, or hydrated potassium aluminum sulfate, and is manufactured for the purpose of water treatment, though it now has many other household uses. The addition of alum to the dirty water will cause the particles to bind together into much larger pieces, known commonly as floc. Once these chemicals have been mixed in, the water is moved to a separate tank for coagulation. Coagulation is the process of floc forming and binding together into larger and larger pieces. Once coagulation has occurred, the water is left undisturbed. The floc slowly settles to the bottom of the tank. This process is called sedimentation. Water is then carefully removed to the filtration tanks, while being careful not to disturb the sediment on the bottom of the tank. The water will flow into the filtration tanks, where it will flow through a number of different types of filter materials. Some filters, such as charcoal, are porous materials and will capture particulates in those pores. Smaller particles will be caught in a finer filter, such as sand, which has much smaller spaces between the grains and is able to trap much more. After several rounds of filtration, water is then moved to a tank to be disinfected, after which it is stored. Disinfection must always happen after filtration in the event something has still passed through. This applies to pathogens, such as bacteria or viruses, which can be killed by the addition of more chemicals, such as chlorine. Chemicals will mix with water during storage, which will also protect water from new infections as it travels from the treatment plants to homes and businesses. It is important to note this does not prevent contamination of abiotic or non-living elements, such as toxins, more dirt, or metals. Time to demonstrate filtration on your own. Start by getting a 2-liter sample from a local pond or another source of standing water. If this is not available to you, add 1 cup of dirt to 2 cups of water and mix until the water is no longer clear. The following list is the materials you will need for this project. First, you will test the dirty water. We suggest using Pure Test Home Water Drinking Analysis Kit for ease and low cost, but feel free to use any test you like. Make sure to follow the specific instructions for your kit, as each kit may differ slightly. Test the water for the presence of bacteria, lead, and pesticides. If you're feeling curious, you can also test levels of pH, phosphates, nitrates, nitrites, or any other metals. Pause the video now to discuss with others the effects of drinking water contaminated with bacteria, pesticides, or metals. Now, pour your water into a plastic water bottle and seal with the cap. Shake vigorously for 30 seconds before pouring the water into a beaker. Allow all the bubbles to surface before stirring in 2 tablespoons of alum into the water. Alum should be readily available at a supermarket or online. Allow your water to sit. Check for clumping every 5 minutes for the next 30 minutes. Record when and how much flock has formed. While allowing the water the 30 minutes for it to settle, you can work on building your filter. Using the top half of a 2-liter soda bottle, attach a coffee filter to the mouth. Use a rubber band to attach your coffee filter. Add pebbles, coarse sand, and fine sand in that order. Each layer should take up about 1/4 of the space available, leaving the top quarter of your water bottle empty. Place your new filter down with the mouth in the beaker. Taking your water, now that the flock has settled, pour it gently into the soda bottle, careful to leave the sediment on the bottom of your beaker. Allow the water to filter. Your final product should resemble the filter below. If you are having trouble, you can watch an animation if you follow the link to the EPA's website found here. Now, take your beaker and repeat the water quality test you have used at the beginning of the project. Record and compare the differences you have found. For a more visual representation, try using a bar graph to compare the changes you see in levels of bacteria, lead, or anything else you have decided to observe. Time to discuss. What differences do you see? Is anything harmful left in the water? Please note, do not drink the water. It is not safe because we have not disinfected it. So, what did we cover? In this talk, we have learned that water is treated to remove bacteria, toxins, and unpleasant tastes or smells from water. The water treatment process includes the following steps: intake, chemical addition, flocculation and sedimentation, filtration, and finally, disinfection and storage. Try this process on your own using the methods described. Thank you for your interest in the water treatment process.